Hello student, today I am going to discuss about the remaining two use of dimensional analysis. Okay, now already discussed two use, how to find the unit by using dimensional analysis and how to check the given equation, physical equation by dimensional analysis. Okay, now today I am going to discuss about two. First is dimensional formula of a physical constant. How to find by using dimensional analysis to find the dimensional formula of a physical constant. And next one is to derive the expression for a physical law or formula by dimensional formula. Number 4 is how we can derive a formula related to physical law by using dimensional analysis. Okay. Now for 3, now let Newton's law of gravitation, we know F equal to capital G m capital M small m by r square, where capital F is the gravitational force, G is the universal gravitational constant, m is the mass of the earth, small m is the mass of the object, and r is the distance between mass of the earth and object. Okay. Now we want to find the dimensional formula of this physical constant capital G by dimensional analysis. Okay, we have to find it. Now we have written all the term within third bracket like this. Okay, we have followed this. Now G equal to this, dimensionally we have write of a dimensional formula F, dimensional formula r square means length square, dimensional formula of capital M and dimensional formula small m. So G equal to, we have got ultimately G equal to m to the power minus 1 L cube t to the power minus 2. This is the dimensional formula of the gravitational constant. So in this way we can find the dimensional formula of a physical constant by using dimensional analysis. Okay. Now next, before going to discuss about this, how to derive the formula, physical formula by using dimensional analysis, before that you have to know the what is principle of homogeneity. Now according to principle of homogeneity, it states that we can add or subtract two physical quantity when they are dimensionally same. Is it clear? We can add two or more, or we can subtract two or more physical quantity when all the physical quantity are dimensionally same. Example, it is written according to this principle of homogeneity, we can add or subtract two physical quantity of same dimension. When both are same, then we can add or subtract the two physical quantity. Okay. Now example 1, a is equal to ut plus half at square. This equation is given to you. Already checked in last class that this equation is correct one. Okay. Now dimensional formula S means here displacement or distance. So m to the power 0, L to the power 1, t to the power minus 2. U means initial velocity, t means time. Okay, and A acceleration and t time. Okay. Okay. Next, now S is the displacement or distance. We know the dimensional formula S, distance or displacement, m to the power 0, L to the power 1, t to the power minus 1. Dimensional formula of ut, m to the power 0, you can find out m to the power 0, L to the power 1, t to the power minus 1. And dimensional formula of at square, this is 1 by 2 is a numerical constant, it is dimensionless. So at square, m to the power 0, L to the power 1, t to the power minus 1. Now this equation is correct one. Now see these two terms. We can add these two terms when both are dimensionally same. See the dimension of this term ut equal to this one, and dimension of at square equal to this, both are same. So in a equation we can add two terms when both are dimensionally same. Okay. Next one, Another example, v square equal to e square minus 2gh. Here v means final velocity, u means initial velocity, g is acceleration due to gravity, and h is the height. Now dimensional formula of v square, we can find this m to the power 0 l square t to the power minus 2, and dimensional formula of u square equal to m to the power 0 l square t to the power minus 2 and minus of this. Now you see already this formula is checked, this formula is verified, and this formula is the correct one. So in a correct equation we can subtract two terms when both are dimensionally same. See, we can subtract use 2gh term or basically gh term from u square term when both are dimensionally same. Both are dimensionally same. This is called property of homogeneity. Okay, by using property of homogeneity we can find out the dimensional formula of a physical constant also in a given equation. Now next question is given p equal to a minus t square by bx. Here p means pressure, x means distance, a and b are the constant. Now we have to find the dimensional formula of a by b from this equation of this equation by using dimensional analysis. Okay, here first we have to find the dimensional formula of a, next dimensional formula of b, then after that we will find the dimensional formula of a by b. To find the dimensional formula of a, here we have to use the principle of homogeneity. Okay, so now this is the question. We have to find the dimensional formula of a by b, already discussed. Now here p means pressure, x means distance, a and b are the constant. Now here we have, by using principle of homogeneity we can find the dimensional formula of a by b. Now how? This is the procedure. Now I have written again this formula, p equal to a minus b square by bx. We have to find this, dimensional formula a by b. Okay. Now from the principle of homogeneity we can write as here we have considered that this given equation is correct. So dimensional formula of a and dimensional formula of t square should be same from the principle of homogeneity. So we can write from the principle of homogeneity dimensional formula of a equal to dimensional formula of t square. So dimensional formula of a equal to m to the power 0 l to the power 0 t square. Okay. Now again we have written equation p equal to a minus t square by bx. Now we have to find the b, dimensional formula of b. Okay. Now dimensional formula of b equal to, we have written this, p means air pressure. So dimensional formula of b equal to m to the power 0 l to the power 0 t square, m to the power 1 l to the power minus 1 t to the power minus 2 m to the power 0 l to the power 1 t to the power 2, and this is the dimensional formula of pressure. Now b equal to, after solving this, ultimately we will get m to the power minus 1 l square t to the power 4. So dimensional formula of a by b equal to a by b m to the power 0 l to the power 0 t to the power 2 m to the power minus 1 l to the power 0 t to the power 4. So dimensional formula is equal to m to the power 1 l to the power 0 t to the power minus 2. Okay. So in this way we can use the principle of homogeneity to find the dimensional formula of a given constant given in an equation. Okay. Now next, number 4, to derive the expression of physical law or formula by dimensional formula. Okay, how to use to derive the physical law or formula. Now one question is given, I am reading out. A particle of mass small m is moving with a velocity v in a circle of radius smaller. Find the expression of the centripetal force F acting on it. Okay, now we have to find the expression of the force acting on that particle whose mass is small m, velocity is v, and moving in a circular path of radius smaller by dimensional analysis. Okay. Now first, this is the procedure. F is the centripetal force. We don't know how it depends on mass, how it depends on this force, how it depends on velocity, this centripetal force, how it depends on the radius of the circle. circular. We are considering that f is proportional to m to the power small a. Similarly, f proportional to directly proportional to v to the power b small b, and f proportional to r to the power c. Now here a, b, c are the constant. We have to find the value of this constant. After getting the value of this constant, we will put this value in this equation. This is okay. This is v to the power. This is equation number 1. Okay, mathematically we can write a proportional to m to the power a, v to the power b, r to the power c, f equal to k, m to the power a, v to the power b, r to the power. This is equation number 1. While k is called constant of proportionality. Okay. Now, 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 after that, this we will write the equation 1 in terms of dimensional formula. So dimensional formula of f means force. So you know dimensional formula of f, m to the power 1, l to the power 1, t to the power minus 2. Dimensional formula of mass, m to the power 1, l to the power 0, t to the power 0, whole to the power a. Dimensional formula of velocity, m to the power 0, l to the power 1, t to the power minus 1, whole to the power small b. And dimensional formula of m to the power 0, l to the power 1, t to the power 0, whole to the power small c. Okay. Here k is the constant of proportion. So it is generally dimensionless. Now m to the power 1, l to the power 1, t to the power minus 2 into k, m to the power a, l to the power 0, t to the power 0, m to the power 0, l to the power b, t to the power minus d, m to the power 0, l to the power c, t to the power 0. Now m to the power 1, l to the power 1, t to the power minus 2, k equal to k into m to the power a, l to the power b plus c, and t to the power minus b. Okay. Now this is the main dimensional we have got in terms of a, b, c. Now comparing power of m, l, t in the equation from both sides. Now from this equation we will compare m, l, t from the both sides. So after comparing m to the power 1 here m to the power a. So a equal to we have got 1. Comparing l to the power 1, l to the power b plus c. So b plus c equal to 1, and t to the power minus 2, there t to the power minus b. So t to the power minus b equal to minus 2. So b equal to 2. Okay. So in this way we have to proceed. Now we can find out the value of a. We have to find out the value of a, b, c. So b equal to 2. Now putting the value of b in this equation, what do we have? B plus c equal to 1. So c equal to 1 minus b equal to 1 minus 2. So c equal to minus 1. Now okay. Now putting all this value in equation 1. Equation 1, we know f equal to l to the power a, v to the power b, c to the power r to the power c. Now putting the value of a, b, c in this equation, f equal to k here should be k, m to the power a means here 1, m to the power 1, v to the power b means 2, so square, r to the power c means minus 1. So minus 1. So f equal to k m v square by r. This is the required formula or expression of the centripetal force. So by using the dimensional analysis, we can find out the formula also. Okay. So just go through this, and I will give some problem. You have to solve this. Okay.